Collecting and organizing univariate data, exercise 3D. Okay, so in this lesson, we're going to be focusing on what's called the measure of dispersion. The measure of dispersion measures how spread out a data set is. So whether all the data is close together, meaning like, let's say I were to ask what is the age of students in a classroom, most of you would be 16, 17, 18 years old. So the spread wouldn't be very wide because all of you guys are 16, 17, or 18 years old. Versus if I asked, what is the age of people in the city of Fontana, then that's going to have a way more widespread from babies that were just being born all the way to the elderly that are 60, 70, 80 years old. So that's what it means by the spread of data, how spread out is everything. So the simplest measure of dispersion is the range, which is found by subtracting the smallest number from the largest number. The standard deviation gives an idea of how the data values are spread out in relation to the mean. The standard deviation is also known as the root mean square deviation. And then they give the formula below. Now, you're not expected to, not only are you not expected to memorize this formula, but you're not even expected to use the formula. Your job is to know how to punch it into the calculator and get your answer. All right, so here's our first example. It says for each of the three data sets in example 3, and find the standard deviation and compare it with the mean. So the number of ice creams sold over a period of 13 weeks is as followed, and then they give us the data, how many ice creams were sold every week for 13 weeks. So like we did yesterday, we're going to enter in all our data into our list. Okay, we learned how to do that yesterday. Once we enter all our data into our list, we're going to run that one variable statistics. So when we run that one variable statistics, and again, we learned that yesterday, it's going to tell us both the mean and the standard deviation. So right here is our standard deviation. So a standard deviation of 30.8 would indicate that the data points are not all close to the mean. So not everything is close to the mean. So again, our mean is 171. If we look here, we have a wide range of numbers ranging, I don't think, yeah, it doesn't look like they have it in order from least to greatest, but it looks like our smallest numbers 146, our largest numbers 238, so that is a wide range of numbers from the mean. And so our standard deviation reflects that by having a standard deviation of 30.8. All right, so here's the next part. 2 dice are thrown 100 times and their total score is recorded in the table. So we have dice. You can roll anywhere from a 2 to a 12 if you have dice, and it shows how many times each number was rolled. So we're going to enter our data into our list. Our first column reflects the number on the dice, or the total number, and then the second column is our frequency. So we're going to run our one variable statistics report, and we're going to find that our mean is 5.82, our standard deviation is 2.8. So, you know, because dice, they range from 2 to 12, it's going to be, you see that the standard deviation number is lower, so the lower the number, the closer the numbers are together. It's not as spread out, so the higher the number, the larger the spread is. So standard deviation of 2.8 is a small value, so most of the points will remain close to the mean. Okay, here's our next one. The weight of cats, of 50 cats, are recorded in the table. So here are the weights between 2 to 3 pounds, 3 to 4 pounds, 4 to 5 pounds, and so forth, and how many cats weighed in each class. So again, we're going to put this information in our list. Now remember, when we're doing a frequency table and we have a range of numbers, we're going to use the number that's in the middle. So between 2 and 3 is 2.5. That's why we have 2.5 right here. And then our second column is our frequency. We're going to run our one variable statistics. There's our mean, there's our standard deviation. Notice the standard deviation is lower than even the other one. So that shows that with a standard deviation of 1.1, it's a small value, so most of the weights will be close to the mean. And we see that here. Most of the weights are around 4.2. So we can see here's 17, that would fall in the range of 4.2. We have 19 that were between 3 and 4. We have 5 that were between 5 and 6. So most of the cats' weights are right here, right? And that's reflected by the standard deviation. That tells us that the weights are not as spread out as like some of the other examples that we had. So now we have the term variance. The variance is the standard deviation squared. While the standard deviation is useful for interpreting the spread of data about the mean, other statistical processes such as least squared regression, probability theory, and investments use the variance. So this is just another way to measure the spread. It's more of a specific use for certain things like it talked about here. So all we're doing is taking our value for standard deviation, that value, and squaring it, and that gives us the variance. The other thing we're going to look at is what's called the interquartile range. So the interquartile range, IQR, is the upper quartile, Q sub 3, minus the lower quartile, Q sub 1. When the data values are arranged in order, the lower quartile is the data point at the 25th percentile, and the upper quartile is the data point at the 75th percentile. The interquartile range is another method for interpreting the spread of data. It is more reliable than the range because it's not affected by outliers. So if you have outliers and because remember our range is basically our maximum value minus our minimum value, but if our min or our max is an outlier, that's definitely going to affect our range. With the interquartile range, it's not affected by outliers. So that's kind of the advantage of using IQR. And again, the nice thing is that you're going to punch all this information into our calculator and it's going to give you all the data that you need. Okay, so we're going to do example 6 again, but this time we're going to use to find variance, the range, and the IQR. So this is the number of ice creams sold over a period of 13 weeks. So we have all of our data here. And we now want to find the variance. So we're going to do exactly the same thing that we've done before. We're going to put our numbers, all our data set in a list. We're going to do our one variable statistics. And if we scroll down, we're going to get the information that we need. So first we're going to find the variance. So remember the variance is basically my standard deviation squared. So I take 30.838, I square that, and I get my answer for variance. For the range, my maximum is given, which is 238. My minimum is 146. I subtract the 2. I end up with 92 as the range. And for my IQR, I take quartile 3 and quartile 1, subtract those two numbers, and I get 38.5. The next example, or the dice, we've gone over this example as well. Same thing, we put our values, our data set in a list, our frequency in the second column, and I do a one variable statistic, and it's the same process over and over again. My variance is basically my standard deviation squared, so 2.8 squared is 7.85. Actually, it's this entire number. I square the entire number and I get 7.85 when I round to 2 decimal places. My range is my max, which is 12, minus my minimum, which is 2. So 12 minus 2 gives me 10. And for IQR, quartile 3 is 8, quartile 1 is 3. 8 minus 3 is going to give me 5. And again, it's the same example as we've done before. I'm just going to go ahead and show you the screenshots here. But again, we're just doing the same thing. Variance, you take the standard deviation and square it. The range, you take the maximum minus the minimum. And interquartile range, it's quartile 3 minus quartile 1. Okay, so there's your assignment for today. If you have any questions, please feel free to ask me in class. And